Hello and welcome back. In this video we will continue to look at some of the fundamental trig identities. We'll finish up with, in fact, we'll finish up with odd and even identities, and I'll describe what this means in a second. And then we'll just do some examples where we will transform trig functions into other trig functions to see exactly what's going on here. So first of all, we know that the sine of an angle is going to be y divided by r, where y is going to be this point that we pick at the end of this line that forms this angle. So again, we have, if we want this angle here, we draw a line, we pick a point. That point is going to be xy. The distance along the line is going to be r. So far, nothing new. But now I want to see what is the sign of negative of that angle. Well, where is negative of this angle? Well, if I have, if this angle is theta, and this is a positive angle, it's going to be going up, going from the x-axis, the positive x-axis, around in a counterclockwise direction. If I were to go clockwise, though, the same angle, I will have negative theta. So the question is, what happens to x, y, and r? Because if I want to find the negative sine theta, I need to know what this point is and what this distance is. Well, I might as well choose a point that's pretty much the exact opposite of this one. So we're still coming over this far. So the x value stays the same. We're still to the right the same amount. Oops. So the x value is still the same. But now I've gone from above the x-axis, where I have a positive y, to below the x-axis, where I have a negative y. The distance from the origin to that point, again, everything is symmetrical, so that distance is still going to be the same. So the sine of an angle is going to be the y value divided by r. Well, now the y coordinate is now negative y, and the r value is still r. So this fraction, negative y over r, is the same thing as negative y over r, which that's the same thing as sine, but with a negative sign out front. So our first identity is the fact that sine of negative theta is equal to negative sine theta. Any function that has this property, if you put a negative sign in the argument for what you're plugging into it, the input, if that negative sign just pops out in front of the function, this is what's called an odd function. If you have taken algebra, you will have seen odd and even functions before. They have special properties, and I'm not necessarily going to go into that. What's important is that a negative sign in a sine function pops out, so the sign does not disappear. However, if we look at cosine, what's going to happen? Well, the cosine is going to be the x value, the x coordinate, divided by r. And if I look at the cosine of negative theta, okay, so now instead of the y coordinate, I want the x coordinate, but the x coordinate stays the same. It hasn't flipped. It's not further to the left or right. It's at the exact same point along the x-axis. So it's still going to be x, and the r value also hasn't changed. So the cosine of negative theta is the same thing as the cosine of theta. So unlike sine, cosine of negative theta is the same thing, I keep doing this, is the same thing as cosine of theta. So here is our second identity. And if this was what's called an odd function, this is what's called an even function. Simply because of some other properties that the cosine has. The odd and evenness comes from a different place. But essentially, if I put a negative angle in the cosine, I might as well just put the positive angle. So that negative sign doesn't affect the cosine, whereas it does affect the sine. So let's go through a few more examples, and we will use our other trig identities to solve these. So the tangent of a negative angle. So again, I could go through this whole process of thinking about, okay, what is a negative angle? What happens to the x and y coordinates? I'm going to use my other trig identities. The tangent of an angle is the same thing as negative sine of that angle, or sorry, is the same thing as sine of that angle divided by cosine of that angle. This is one of our quotient identities. The tangent is sine divided by cosine. So the tangent of negative theta is the sine of negative theta divided by cosine of negative theta. And we just learned that sine of negative theta is negative sine theta, so I can pull that sine out, or sorry, pull that negative sine out. The cosine of negative an angle is just the cosine of that angle. And now look, I have sine divided by cosine with a negative sign out front. So I can simplify that. Tangent of negative theta is the negative tangent of theta. So this is going to be an odd function as well. You plug in the negative sign, you can pull out the negative sign. Let's look at cosecant. The cosecant, if I want to write it in terms of the functions I have before, the cosecant is 1 over the sine. So the cosecant of negative theta is 1 over the sine of negative theta. And again, sine is odd, so I can pull out the negative sign. And 1 over sine is the cosecant. So cosecant of negative theta is negative cosecant of theta. You can pull out a negative sign out of the cosecant. So this is also an odd function. Let's look at the secant. Again, writing this in terms of functions that I've already looked at, the secant is 1 over the cosine. So let's flip it over. So secant of negative theta is 1 over the cosine of negative theta. But the cosine doesn't care about the negative sign in the middle. It's the same thing either way. So let's write it without. So this is just going to be the cosine of theta. And oh hey, look, 1 over the cosine, that's the secant. So the secant is another function that if you plug in a negative angle, it's the same thing as just plugging in that positive angle. So this is an even function. And then the last one, the cotangent. Again, this is going to be 1 over the tangent. And if I'm taking the cotangent of negative theta, this is going to be the tangent of negative theta. And I can pull out the negative sign because we already learned that about the tangent. Tangent of negative theta is negative tangent. So I can pull out that negative sign. And I get negative cotangent. So this one is also an odd function. So this is going to be an odd function because if you plug in the negative sign, you can pull it out front. So what I would like to do for examples and how to use all of our trig identities, I'm just going to pull up an example question from the textbook and let's look at this. So for each expression, we want to choose the expression that completes the identity. Sometimes both of them will have to be rewritten. So let's look at this first one. I have negative cotangent times sine. Negative cotangent of x times the sine of x. And we have to simplify this to make it match one of these guys. So let's come back and write that down. So we've got negative cotangent times sine. Negative cotangent, and they have the cotangent of x times the sine of x. It doesn't matter what the name of the angle is that we plug in here, as long as we're consistent. So here, if I have negative cotangent of x is equal to sine of x, my best trick that I know how to tackle trig functions is I like to turn everything into sines and cosines. So let's turn this into sines and cosines. So sine of x is already a sine or cosine. I don't have to change that. Cotangent, I do want to change that a little bit. The cotangent of x, well, I know that this is going to be 1 over the tangent. And I can turn tangent into sines and cosines. Tangent is sine divided by cosine. So then if cotangent is the reciprocal of tangent, that means that cotangent itself is going to be cosine over sine. So let's plug that in here. I know that the cotangent is equal to cosine over sine. So if I plug that in, the negative sign doesn't go away, but now I have cosine over sine times sine of x. And now I can see that I've got a sine x and a sine x, and those are going to cancel. So what I'm left with is negative cosine. So when I come back here, that is in fact one of my options. Negative cosine of x works. So that is going to be that one right there. Nice. So let's look at the next one. I've got secant squared of x minus 1 is equal to something. Okay, so let's write that down. Oops, I don't want to write in red. I've got secant squared of x, minus 1, and that's going to be equal to something. Well, right away, I see, oh, I've got a squared trig function here. This looks like one of our Pythagorean identities. So let's remember what our Pythagorean identities were. So we had sine squared plus cosine squared is equal to 1. And we don't have a secant in there. So that's fine. Let's look at 1 plus tangent squared is equal to excuse me, secant squared. I'll have to get a drink of water soon. And here we go, oh, wait a second. This Pythagorean identity has a secant in it. So if I rearrange this, if I subtract secant from both sides, and then I subtract tangent from both sides, we can see that 1 minus secant squared is going to be equal to negative tangent squared. No, in fact, that's not how I want to rearrange it at all, is it? I want secant minus 1. So if I subtract 1 from both sides, this will be a lot simpler. If I subtract 1 from both sides, I get secant squared minus 1 is just the tangent squared. And the tangent, I know, is sine over cosine. And then from here, this is just going to be sine squared over cosine squared, which is in fact one of the answers. Sine squared over cosine squared. and I will look at the next ones in the next video.